introduction. And so let's start with this last session, heterogeneous high-performance computing at NextLab. So this will be a rapid overview of this research line. So to start, let me just introduce myself again. I'm Guido Walter Di Donato. I'm a postdoctoral researcher here at NextLab. I got my bachelor and master of science in bioengineering and biomedical engineering from Politecnico di Milano and UIC, and my PhD in information technology in the area of computer science and engineering here at Politecnico. My interests mainly are around high-performance computing applied to graph analytics and graph machine learning, and bioinformatics and health informatics. And if you followed the first section, you probably already know that I'm also interested in entrepreneurship, and I'm the CEO of Genogra. So in this talk, I will provide a rapid overview of our research line about heterogeneous high-performance computing. And we start from the context that is the need for more efficient architecture. So in this research line, we are focusing on some compute-intensive algorithms and computations that require to process a massive amount of data. And for this kind of computations, general-purpose architectures are already proven inefficient to do this massive work. So hardware accelerators like GPU and FPGA offer way better performance to speed up this kind of processes. But in this research line, recently, we have also started to explore another direction to speed up this kind of programs. And this is the case of quantum computing that we will explore later. So we are also trying to radically change the paradigm of the analysis and of the computation to get some outstanding results in terms of performances. So moving to what is the high-performance, heterogeneous high-performance computing at NextLab, we have mainly two kinds of directions. The first one is using GPU and FPGA to speed up some of the processes. The other direction is using instead quantum algorithms and quantum computers. So moving to the first kind of works that we do at NextLab, let's start with GRCUDA. GRCUDA is an example of what we do to, let's say, make GPU computation more accessible. So GRCUDA is basically a polyglot API that gives CUDA to every programming language, high-level programming language available in the Graal VM by Oracle. So this project was initially created by Oracle and NVIDIA, is currently maintained by us, and we gifted GRCUDA of an asynchronous scheduler both for single GPU, but more importantly for multi-GPU. We achieved multi-GPU scheduling in an automatic way by minimizing the data transfer and maximizing the GPU utilization through some policies that take decision on how and where to schedule the kernel execution and at runtime. This project was very important for us, and we achieved an automatically achieved a performance of 80–90% with respect to the CUDA C++ peak performance with respect to manually optimized implementation. So these are very remarkable results. And for this reason, we asked ourselves, can we do the same in a distributed scenario? So can we do this autonomous scheduling on multiple accelerators in a distributed scenario? And this is what the talk by Jan that will follow and that will present GR out will be about. Another kind of work that we do in our lab is to accelerate some heavy computations. In particular, one of our field of application is that of graph analytics. In this case, we know that these huge graphs can be analyzed very rapidly by using them in form of matrices and using some hardware accelerators. And this is exactly the kind of work that we do in our lab. An example will be provided by Mauro Famà that will present a multi-GPU top-K sparse eigensolver for graph analytics. We also used GPU and FPGA to accelerate genomic computation. This is mainly the work by Alberto and Beatrice. They achieved some huge speed up by using this kind of architecture. And in particular, with the work by Alberto, he tried to understand if in a certain way he could generalize the optimization process. And this will be the topic of the Starlight talk that Alberto will present after. Finally, to conclude this overview, this very rapid overview of our work, let's mention the final kind of work about the quantum computers. These are new way of achieving some exponential speedups for certain kind of algorithms. This is an entirely new paradigm of computation that is based on quantum mechanics. So we are not using any more bits, just 0 or 1s, but we are using qubits that can have as values some superpositions of 0s and 1s. So the output of this algorithm is generally probabilistic, and they are great, for example, for some specific kind of computation like combinatorial optimization. But this kind of computations comes with many open challenges. In particular, for example, the topic of the talk by Marco Venere will be about the need of mitigation, of error mitigation, for example, in combinatorial algorithms. So this is mainly the overview of our work in the HHPC research line. Thank you for your attention. And now